Okay, so we are back and we are doing our last section of the year, and it's 7.9, which is called More Hidden Identities. In today's job, you're going to be able to solve trig equations strategically. And what additional tools and ideas can I use to solve trig equations? And here's the big thing: when you're solving trig equations, you're really relying on like a multitude of things. Number one, you are relying on your solving equation skills, like from way back when it started, probably in kindergarten if you really want to trace it back. And they were really honed in seventh and eighth and ninth and 10th grade, and probably 11th grade. And then you're also relying on your trig knowledge. Okay, and we're putting those two things together, and we're going to be able to solve trig equations strategically. So, what additional tools and ideas can I use to solve trig equations? So, it says, note, because trig functions are periodic, trig equations generally have multiple solutions. In this task, you should find all solutions of trig equations by representing a sequence of solutions using the form answer plus k pi n, where k pi represents an interval between successive solutions. Previously, Javier observed that he might need to change the form of the trig expression in a trig equation before he could use an inverse trig function to solve the equation. Changing the form of a trig expression involves looking for trig identities that apply to the expression. Sometimes you have to manipulate the expression algebraically before you can identify a trig identity that might apply. Here is a summary of how Javier would have solved a problem previously. You can use his strategy to solve the remaining problems in this task. So solve 2 sine x cosine x plus root 3 plus 2 root 3 over 2 equals to root 3. Number 1, do you see a trig identity? If so, write the equation in an equivalent form using the identity. If not, you can manipulate the trig equation algebraically. Which approach do you think Javier would need to take for his first step to solve this problem? Use an identity or manipulate the equation algebraically? Okay, go ahead and think about that. And while you're thinking about it, it's okay if you are wrong, right? Okay, so if you said either one of these, you're absolutely correct. So number one, some of you recognize 2 sine cosine, which is a trig identity, and I can show you here. So you're looking for 2 sine cosine, 2 sine cosine, 2 sine cosine. And some of you are like, oh, it's right there, Miss Johnson. It's the double angle formula. So sine of 2 theta equals 2 sine cosine. So I'm going to write that down. So when I need it, I'm going to use it. So I'm going to write down this identity. So sine of 2 theta equals to 2 sine cosine. Okay. And so this is an identity that we are using, that we are going to use rather. Okay. And the reason why we're going to use it is because I see part of it in my equation. Specifically, I see this part right here. So in a little bit, you'll see me substitute the other side in so that it can go in there instead. And the reason why is because if you're solving equations, you want your variable to be as simple as possible, right? And if you look at the right side of this the identity, it's not simple. You have two of them. You have a theta here and a theta here. Versus the left side, you only have one theta. So remember, like back in 7th grade, one of your jobs was to put all the variables on one side and you combined like terms. Well, that's kind of what you're doing here, because now I have one theta as opposed to two separate thetas that are now being multiplied, right? I'm taking the sine of theta, multiplying it by the cosine theta. So but first, I also see addition. And if you remember our ideas, we use SADMAP. So I'm going to get rid of that plus root 3 over 2 and move it to the other side. Okay. So I am going to move that to the other side. So it's going to look like Should I go on this side? Probably this side. All right. So that's going to look like 2 sine theta cosine theta plus root 3 over 2 equals to root 3. Okay. So then I'm going to subtract root 3 over 2 minus root 3 over 2. And I'm going to use, like, going back to 5th grade fractions, I'm going to be doing that. Okay. So the left side still stays as 2 sine cosine. And then in my head, right, I'm going to do this off to the side. Root 3 minus root 3 over 2, I need a common denominator. So my common denominator in this case is going to be a 2. So I'm going to multiply this one by 2 over 2. Oops, 2 over 2. And then now I have 2 root 3 minus root 3. So 2 root 3 minus root 3 all over 2, right? Which just is root 3 over 2. Is everybody okay with that? So now when you're doing these, don't get bogged down by the fractions. Just do what you did before. Get a common denominator by getting the equivalent fraction and then subtract just like you did before. Subtract the numerators, keep the denominator, right? So now I know you're tempted. To divide by 2, but don't, because remember, we want to use this identity. So instead of writing 2 sine theta cosine theta, on the next line, I'm going to write sine of 2 theta equals to root 3 over 2. Okay. 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 And then it says idea number 2. Repeat idea number 1 until you have isolated the trig function on one side of the equation. Okay. So now I have isolated the trig equation. I just have sine 2 theta. Now here's where your choice comes in, and basically the way I taught you. Either you're going to recognize that this is a special right triangle because of your opposite over your hypotenuse, and you're like, hey, I know you. I know root 3, I know 2. So whenever the root 3's come up, whenever the 2's come up, 1's and root 2's come up, I'm like, oh, you're probably one of my special right triangles. Okay, and the more you are familiar with that, the smoother in terms of how you are solving this. Okay, so if you are using the triangle, you're going to go like this. You're going to go, hey, the opposite is root 3, and the hypotenuse is 2. So if you didn't know that this was a 30, 60, 90, you could then plug this into your calculator. But again, the calculator, he's so tricky because he only gives you one answer. So sine inverse of square root of 3 divided by 2, it gives you that crazy number, which if in degrees, it's 60 degrees. But if you were comfortable with looking at this, you already knew that this was going to be your pi over 3 angle here, right? So, but the problem is, I'm going to tell you, the problem is that only gave you one of the answers. Okay, that only gave you one of the answers. Okay, so I'm going to hold back on the rest of the answers just for now. Okay, so I'm not technically done solving because theta is not by himself. So now I'm going to just divide both sides by 2 or multiply by half. That's the same thing. I'm sure you guys knew that. So theta equals to pi over 6. Okay, so this is the answer in the first quadrant. Okay, now because we have to find the other solution, you're basically asking yourself here at this point right here, where else is sine positive besides the first quadrant? This is the question you need to ask yourself. So then you either take it to here, all students take calculus, or you realize that sine is the y variable. So I'm really asking where else is y positive. And you're like, oh, it's the upper quadrants, first and second. So here's going to be my second answer as well. This guy here, which that means that 2 pi also equals to 2 pi over 3. I mean, sorry, not 2 pi, 2 theta. 2 theta equals to 2 pi over 3. And of course, you divide by 2 on both sides or multiply by half, and then you get theta equals to pi over 3 because the 2's cancel, right? And you're like, wait a second, Miss Johnson, you said that was the only answer in the first quadrant. That was the first answer in the first quadrant. But now you figure out that there is multiple answers, right? So what I now need to do is I need to find all of the answers. And so if you look, so sorry, I wasn't even paying attention to these letters here. Okay, so D, apply the inverse trig. We did that. So then it says idea number 4. This process finds an infinite number of solutions. Since trig functions are periodic, adding and subtracting multiple increments of the period will generate new solutions. Right? This infinite set of solutions of the form answer plus q pi k, where q pi represents the interval between successive solutions. So if you, it said something very important here. Increments of the period. Okay, so what does that actually mean? Okay, so what that means is we have to go back and figure out what the period is for that function. So our period is by looking at sine of 2 pi. If we were to graph this thing, do you guys remember our equation was 2 pi equals bp, where p is the period and b is this number right here? So then we're just going to plug in b and then figure out our period. So that means 2 pi equals 2p. That means p equals 2 pi. So then it says, add this on to your answers. So my answers were pi over 6 and pi over 3. And then they said, add this to it, which is basically this, the pi. So I'm going to add plus k, or actually plus or minus k pi, right? K is any number I want it to be. Okay, it could be any whole number. And I'm going to do the same for here, and it's going to hit all of my answers. Okay. So if you're good with the pi over 6 part, just know that I'm trying to hit all of the answers. And so I added k periods to it. And the way I found my period is by looking at the coefficient of your theta. Okay, so then it says, part F, since the inverse trig function used in number 3 is a function, we only get one unique value as a solution to the inverse trig expression. While there may be another solution in a different quadrant of the unit circle, find the alternate solution and correspond. Okay, so that's when we found pi over 3. So this one is going to be pi over 3 plus k pi. Okay. Okay, hints for solving trig equations. Graph of trig function and the unit circle can be used as tools to help reason about the solutions of a trig equation. Illustrate how a graph of the unit circle can help you find the solution. Okay, so let's do the graph first, and then I'll explain what that means. And I'm going to take it from, you could go from here, right, the original equation, but I want to explain it from our double sine of 2 theta equals to root 3 over 2. You could do it from either one, but I want to explain it from there so you can get that period kind of understanding. So sine of 2x, and then I'm going to put y equals the square root of 3 over 2, right? And then I need to switch this back into radians so we could see this. And I'm going to zoom in here. So notice my answer is pi over 6. My answer is pi over 3. My answer is 7 pi over 6. My answer is 4 pi over 3. And I'm getting all of these. So every time you see a 13 pi over 6, that's this answer that we came up with. Where are you? Where it says pi over 6 plus k pi. We're just adding pi's to it. So the next is going to be another 19 pi over 6, and then another 25 pi over 6. So it's going to get all of those pi's, including on the negative side. These ones here that have the denominator of 3 are these one is this answer here with pi over 3 plus k pi. So pi over 3 plus k pi is going to be pi over 3 plus 4 pi over 3 plus 7 pi over 3. And we're just going to keep adding pi's to it, 10 pi over 3 and continued. Okay. You could also look at this as, I'm going to turn these off for a second. You could have also checked your answer using our original equation that they gave us, and you should get the same exact answer. So 2 sine x cosine x, and then plus square root of 3 over 2. And I want to set that equal to y equals 2 square root of 3. And if you notice, where's my 0? There it is. If you notice, your answers is pi over 6, 7 pi over 6, and you're getting the same values for our x. Okay. And if you're wondering what that 1.732 is, that's this down here. That's our y. That's our other side. Okay, so this is what the graph looks like. Hopefully that makes sense to you. Okay, so let's explain what the unit circle is talking about. Now, the unit circle is talking about when we got to that point, and again, I'm going to go from the point of sine of 2 theta equals to root 3 over 2, I think it was, right? So if you think about what root 3 over 2, and I drew this picture for you, right? It looked something like this. It's not exactly there, so, oh, it actually is there, sorry, my bad. Yeah, because it's root 3 over 2. So here's, and it was these two triangles, right? Where these points here, the y was root 3 over 2, and the y here was root 3 over 2. They wanted me to find out those x values. And because this is a 30, 60, 90 triangle, the x values were going to be your root 3 and your 2 pi over 3. Okay. So those are your two reasons why they're. So now what you're going to be doing is you're just going to be solving these equations, and there's a lot of different ways to solve them. Okay. So I'm going to give you a toolbox that helps you, and I'm just going to build the toolbox as I go. So the first thing I like to do is I like to use SADMAP. Now I use SADMAP straight off to isolate my cosine, my sine, my whatever my trig value is. So SADMAP to isolate trig function. Okay, so go ahead and do that. Isolate cosine as best as you can by using SADMAP, and then I'll add more to my list of my tools for solving. Okay, so the very first thing that I would do here is I would divide by 2 because I don't see any adding, I don't see any subtracting, but I do see multiplication, so I can undo that by dividing by 2. So then I get cosine of 3x is equal to root 2 over 2. And some of you are like, oh my, Ms. Johnson, I see the root 2 over 2. That's my That's my buddy. It's a 45, 45, 90 triangle. I know exactly what that is. Exactly. So for those of you who don't see that, that is okay. Okay. That is okay. But I just need you to kind of try to get better at practicing and looking for those things. Okay. All right. So, so because this is a 45, 45, 90 triangle, I'm going to be drawing him here. And this is root 2 here. This is 2 here. But where else? Your question should be, where else is cosine positive? So I keep asking that question, right? So once you do isolate your trig function, you're going to use the inverse. But your question should always be, okay, so let's write another one. So use trig inverse. But you have to ask yourself the question, where else, else is that trig function positive or negative? So in this case, I'm just going to write cosine positive or write whatever it is. This is an important question for you to find all of your answers. Okay. So here, I'm going to ask that question, where else is cosine positive? Question mark. So cosine's positive down here too, right? So this is going to be root 2. This is 2. So this is actually negative root 2 because this is a 45, 45, 90 triangle. And I don't know why I labeled that triangle because I actually don't need it. So I already know that this answer in here is pi over 4. So that's one of my answers. So that means 3x equals to pi over 4. And my next answer is going to be here, right? At 3x equals to whatever that number is. Now, some of you have been following me and you understand how to do this. If you don't, I'm going to go through a quick little idea here. So over here, this is pi, but in terms of 4, if you had a complete pizza, like a whole pizza, and I sliced it into 4, you should have 4 slices of the 4. And if you go all the way around to here, you should have 8 slices of the 4. That means 2 whole pizzas, right? But then someone took one away. And so now you're left with 7 pi over 4. So that's how I calculate. Oops, 7 pi over, I just wrote that wrong. 7 pi over 4. Okay, so then what I'm going to do is I am going to, and this is another option for you, for those of you who didn't want to like look at the period. This is another way for you to do it. So I want pi over 4 plus all of his circles. So I'm going to put plus 2 pi. And I'm going to put plus 2 pi. I want all of those circles, okay? So this is going to be all of them. If I add that 2 pi, I'm going to get it there. I'm going to make this really messy of a drawing. I'm going to get pi over 4, and then I'm going to get pi over 4 plus 2 pi, and then I'm going to get it plus another 2 pi, plus, right, all the way through. So I'm going to put 2 pi k, and I'm going to put a k on the end. And that k is going to add as many circles as I want. 2 pi is a whole circle, a whole rotation. K is however many rotations I want. And remember, we can always do plus or minus, okay? So just remember, we're doing plus or minus all of that. Okay, then the last thing is you're like, well, Ms. Johnson, you never solved for x. Okay, now I'm going to solve for x with that 2 pi k there and watch what happens. So I'm going to divide by 3. 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 Okay, so my answer turns into, get this, x is equal to pi over 12. Okay, pi over 12 because 4 times 3 gives you my 12. Okay, plus or minus 2 pi over 3k, and that is, you'll see that that's your your period as well. So for those of you who are like, wait, what? And then so the other side is going to be 7 pi over 12 plus 2 pi over 3k. So in case you don't believe me that this business here, where did the 2 pi over 3 come from? It comes from this. So if you remember, our period is 2 pi equals BP, where B is that 3. So I'm going to write 2 pi equals to 3p. So period is 2 pi over 3. So notice this guy here is this guy here. And we said earlier that you're going to add increments of the period. So this is another way for you to get that period in there without you calculating the period off to the side. So I gave you a choice. Which way do you like better? I personally like this way, by adding 2 pi k and then dividing out by whatever number that they give you and making sure that that makes sense. Okay. So what was hard about this problem? Is it the isolating your cosine? I think for the most part, what I've seen mostly is students having a hard time finding the second, meaning this guy here, the second answer. Okay. So again, if you're familiar with your graph and you're familiar with all students take calculus, this will help you find that second answer. Okay. Okay. I am going to show you these next ones, but I'm not going to show you every single one. I'm just going to start off with this next one. And the way this next one looks is I need you to kind of remind yourself that this looks like something, right? This says sine squared minus sine minus 2. And if you really think about it, this kind of reminds you of quadratics. So I'm just going to go like this. This kind of reminds me of, I guess I shouldn't use x because x is already used. Sorry. I will use like y squared minus y minus 2. And you know how to factor that because that's something that you learned, in the past when you learned quadratics. So I'm just going to remind you of how to do this, right? So before, when you factored this, you asked yourself, okay, well, what two numbers multiply to get to -2, but add to get to -1? And you're like, oh, that's -2, -2 times +1, right? And then you put y's in front of it, right? And you're like, oh yeah, that's right. And then you'd set it equal to 0 and then you'd be on your way. But here I'm going to erase y and instead just put sine of x and sine of x. And I know this feels weird. The first time that you factor using trig functions, it feels weird because you've never factored using trig functions. But factoring works on trig functions because trig functions are just number. When you take the trig function of an angle, it's just a number. So really you are just using numbers there. So the next step for this would be to set each piece equal to 0. And this is where it gets a little crazy. So sine x, minus 2. I'm trying to scoot over because I ran out of room right there. And then sine x equals to -1. Okay. And then so then you go, okay, sine x equals to 2 and sine x, and then sine x equals to -1. Some of you recognize that sine x equals to -1 is down here. That's telling you on the unit circle, it's this angle here. So that's just x equals to 3 pi over 2. And then I'm going to add my 2 pi k. So there's one of my answers. And then sine x equals to 2 is kind of funny for you. So I'm going to show you using the calculator. So sine inverse of 2. And it says undefined. Now, let me explain why this is undefined. First, I'm going to show you a graph. So whenever I graph the function sine of x, let me turn this other guy off and this guy off. There you go. So when I look at the function sine of x, It lives between 1 and negative 1. It lives between positive 1 and negative 1. Okay. Another way for you to look at this is if you think about what sine is opposite over hypotenuse. Does it make sense for your hypotenuse to be a 1 when your opposite is 2? Does it make sense for your hypotenuse to be 1 when your opposite is 2? And you're like, no, Miss Johnson, because in a right triangle, I've learned this from 7th grade, that your hypotenuse has to be longer than your opposite or either of the legs. So this one produces no solution. So this is no solution here. But here's my answer because they gave me an answer here. So they asked me to find all the solutions. There it is. X equals to 3 pi over 2 plus 2 pi k. Ms. Johnson, should I write no solution? No, you should not write no solution because that's not true. But there is no solution for the one on the left. Yeah, for the equation on the left, there is no solution. But for the whole equation, there is a solution. Okay. So similarly, you would factor number 4. Okay. Similarly, you would factor number 4. So go ahead and try factoring number 4, and then we can check our answers in class. So this is where I'm going to end it. I'm going to come back and do a second video.